on this page, we're interested in seeing if there's evidence associated with a study that has a cause and effect relationship, and we discussed that this would only happen if it's an experiment and not just an observational study. So we're gonna focus more closely on studies that investigate a relationship between two variables. In these types of studies, one variable is the explanatory variable, so that's probably a good thing to write down. We'll define it soon. And the other is the response variable. So just by, I guess, the terminology used there, you can probably infer what they mean. Explanatory variable is probably the one that would explain a change in the second one. It's the one that you're maybe manipulating that would maybe make a change in the second variable. The response variable is the one that would be affected, I guess, or the one, that you manipulate the first one, the second one is changed or affected. The response variable is the focus of the study, the outcome that we examine. The explanatory variable is the variable that we think may influence the response. We can think of explanatory variable as the predictor of the response. So it might be good to kind of write those definitions down, maybe pause and write those down. It's harder to provide evidence of a cause and effect relationship between two variables than to provide evidence of an association, as we've kind of discussed before, between the variables. The strongest evidence of a cause and effect connection comes from a well-designed experiment. In an experiment, researchers take steps to ensure the explanatory variable is the only thing that impacts the response variable. That's very hard to do. They try to remove all other factors that might affect the response. Then they manipulate the explanatory variable and see if it causes a change in the response variable. For this reason, experiments give the strongest evidence that an observed association between the two variables is actually a cause and effect relationship. We will learn more about the ways researchers control the influence of other factors later in the unit. Researchers may examine the relationship between the two variables in an observational study, but a single observational study can only provide evidence of an association. So that's an important thing to notice. They said researchers may examine the relationship between two variables in an observational study, but also a single observational study can only provide evidence of an association between the two variables and not a cause and effect relationship. We've said that in a previous page. So for example, researchers may compare cancer rates of smokers and non-smokers. They don't manipulate anything. They don't manipulate the explanatory variable, which is smoking, because that would be kind of not right. You can't force this group to smoke and this group to not smoke. That'd be kind of, that would not be very nice. To see if it affects the response of cancer, they simply collect data and make observations about it. So maybe they just take a group of people and they ask, did you smoke or not? And then study if there's an association between that and cancer rates. In an observational study, researchers may take steps to reduce the influence of other factors on the response, but it's very difficult in an observational study to get rid of all the factors that may have an influence. So for example, when examining medical records, researchers may remove people from the cancer study who have a family history of cancer, because a family history of cancer could, of course, affect whether that certain patient has cancer. It might not be due to smoking or not smoking, but there may be other factors affecting cancer rates, such as diet, that they can't address. For this reason, observational studies can suggest an association between two variables, but taken alone, an observational study does not give convincing evidence of a cause and effect relationship. Yeah, because you're studying these two variables. There might be one affecting the other, but there are so many other outside sources that you might not even be taking into consideration that might actually be more a cause of cancer than the smoking. But now let's talk about evidence, an example of evidence for a cause and effect relationship. So this one's a specific example. It says here, when women go through menopause, the production of hormones in their bodies changes. The hormonal changes can cause a variety of symptoms that may be reduced by hormone replacement therapy. So back in the 1980s, researchers decided that they wanted to do a hormone replacement therapy because women, I think, going through menopause have a lot of symptoms that aren't super fun to go through. So they figured, well, before menopause, you have certain hormones as a woman, and then after, they're changing. So maybe if we replace those hormones and try to make your body, try to manipulate it so your body has the same hormones they had before your menopause, maybe you wouldn't be so affected, and maybe the symptoms won't be so bad. That was the idea. So it was, a nice idea. Let's see how it goes. In the early 1990s, that's, maybe 10 years later, because they did the hormone replacement therapy starting in the 80s, observational studies suggested that hormone replacement therapy had additional benefits, including reduction risk of heart disease. For example, researchers compared women who took hormones to those who did not take hormones. Health records showed that women taking hormones after menopause did have a lower incidence of heart disease. So you would probably see that the people that came up with this hormone replacement therapy, the medical research, they'd probably want those to be associated because they want to sell more of this. They want doctors to use this, and of course they'll make more money, right? But women who take hormones are different from other women. They tend to be richer, so they have good health insurance, or they can afford this hormone replacement therapy, and more educated they have better nutrition, of course, because they have more money, or better insurance or whatever, and they visit the doctor more frequently as well. These women have many habits and advantages that contribute to good health, so it's not surprising that they have fewer heart attacks. So with that in mind, can we actually conclude from these studies that the hormones caused a reduction in heart attacks? No, I don't think so, because they're confounded. That's a new word that might be good to write down. The results are confounded by the influence of these other factors. So we'll talk more about that, but confounding variables, we'll talk, in a few paragraphs down, we'll talk more about that. In 2002, Women's Health Initiative sponsored a large-scale, well-designed experiment to study the health implications of hormone replacement therapy. In this experiment, researchers randomly assigned over 16,000 women to one or two treatments. One group took hormones, the other group took a placebo. You've probably heard that term before. A placebo is a pill with no active ingredients that looks like a hormone pill. So some people call it a sugar pill. I think that means it might just be made of sugar, meaning that it has no hormones, but maybe the women that are taking it think it does. The experiment was double-blind. That's probably, these terminologies, the ones that are in bold, are probably good to write down in your notes. The experiment was double-blind, just blind, not double-blind, but blind, means that women did not know if they were receiving hormones or the placebo. Double-blind means that the information was coded. So not only the women didn't know which pill they were getting, the hormones or the non-hormones, but also the researchers administering the pills didn't know which treatment the women received. Something like that they might do, the researchers not knowing which pill they're giving, because you might not even realize it, but as a researcher you might act differently as you hand the woman the pill. You might, the way you hand it to them, they might get this feeling that it is the placebo or it's not. You might not mean to as a researcher, but you might, so that's better if you don't even know, so you don't even give off the vibes of, yes, this is going to work, or yes, look at this is just a sugar pill kind of thing. Then after 5 years, the groups taking the hormones had a higher incidence of heart disease and breast cancer. So think about that. That's the opposite of what we thought. In the beginning, it made it seem like the hormone replacement therapy was making women's health better than it was hurting. But it actually turned out that the women that were taking the hormones had a higher incidence of heart disease and breast cancer. This is exactly the opposite result that the results found in the observational studies. In fact, the differences were so significant that the researchers ended the experiment early. The National Institute of Women's Health declared that the observational studies were wrong. Hormone replacement therapy to treat menopausal symptoms is now rarely used. Okay, what's the main point here? The main point is that in this observational study, and all observational studies, we can provide evidence of a link or an association between the two variables. But other factors may also influence the results. So in the above example, it seemed like this hormone replacement therapy was causing women to have a reduction. They are less likely to have heart disease. But there were, like I mentioned, there are other factors. Women that take hormone replacement therapy probably are more wealthy. They have more access to health care. They go to the doctor more. They have better nutrition because they're wealthy, things like that. And it really turned out that those women were actually getting heart disease more often and breast cancer. So all those other variables, they're called confounding variables. That's probably a good one to write down. Confounding variables are being, what is the average annual income of these women? The women that got their hormone replacement therapy probably had more money, more access to healthcare. Yeah, access to healthcare, insurance, that kind of thing. Those are confounding variables. The influence of confounding variables on the response variable is one of the reasons that an observational study gives a weak and potentially misleading evidence of a cause and effect relationship. A well-designed experiment takes steps to eliminate the effect of confounding variables, including random assignment of people to treatment groups. use of placebo, or blind conditions. We will learn more about these ideas later in this unit. Using these precautions, a well-designed experiment provides convincing evidence of cause and effect.